Let's explore the steps needed to implement rapid spanning tree in an environment with Cisco Meraki and Cisco Catalyst switches. We will begin by reviewing the Layer 2 switching topology of our network environment. Our topology includes a Catalyst switch operating as the core switch of our network, interconnected with two Meraki switches. Our Meraki switch on the left is currently operating as the root bridge of our spanning tree deployment. While the Catalyst switch is operating rapid per VLAN spanning tree with a number of VLANs and spanning tree instances, we'll be adding our Meraki switches into the spanning tree instance operating on the native VLAN of the Cisco Catalyst switch. Let's review the VLAN implementation running on the Catalyst switch next. We will begin by recognizing the variety of VLANs operating across our Catalyst switch using the command show VLAN brief. We can also view the individual spanning tree instances that are running per VLAN for customizing traffic flow using the command show spanning tree summary. We could then view the VLANs operating on the trunk ports of our Catalyst switch, which does include the native VLAN, by using the command show interface trunk. We can see that native VLAN 1 is operating on our trunk interfaces, connected to our Cisco Meraki switches. This will be the VLAN that our Meraki switches will be sharing a spanning tree instance with. Let's review the rapid per VLAN spanning tree implementation running on this Cisco Catalyst switch. We will begin by using the command show spanning tree VLAN 1. At this time, we can see that one of our Meraki switches is operating as the spanning tree root bridge of our network for VLAN 1. Cisco best practices dictate that the core switch, our Cisco Catalyst switch in this case, should be operating as the root bridge. The priority of the Meraki switch is listed as the root ID priority value of 16,384, while our Catalyst priority value is 32,769. That's 32,768 plus 1, which is the VLAN ID. We need to lower our priority value on our Catalyst switch or increase the priority value on the Meraki switch. Let's take a look at one of our switches here on the Meraki dashboard. This switch, the IDF switch, is the switch on the left side of our original topology. When I access this Meraki switch and I scroll down, we will see that this switch is acting as the root bridge for the rapid spanning tree protocol. If we want to correct this, we can either edit the priority value of this switch to be higher than the Cisco Catalyst switch, or we can access our Cisco Catalyst switch again and ensure that the priority value of the Cisco Catalyst switch is lower than this Meraki switch. We will do that next. We've returned to the Cisco Catalyst switch CLI, and again we can see that the current root bridge ID has a priority of 16,384, which is the Meraki switch. We are going to access our configuration mode, and we will use the command spanning tree VLAN 1 priority followed by a value that's lower than 16,384. We will use 8,192. With our Catalyst switch priority value lowered to 8,192 on VLAN 1, we will cause the Catalyst core switch here on our network to take the root bridge status. The Cisco Meraki switches will now find the best paths to reach the root Catalyst switch. We can verify the RSTP root bridge selection by utilizing our previous command of show spanning tree VLAN 1. We now see that our priority is 8,193, which is the value 8,192 plus 1 for VLAN 1. We also see that this bridge is the root, refers to our Cisco Catalyst switch. We will move to the dashboard next to verify spanning tree convergence. we will verify spanning tree connectivity by accessing our IDF switch that was previously the root of our network. Within the IDF switch, I can scroll down and look on the left side, and now the Meraki IDF switch recognizes that the MAC address of our Cisco Catalyst switch and the priority being reported by that switch is now the root bridge of the spanning tree instance. We have port 1 and port 2 being listed here because it is a bundled link interconnecting our IDF switch to the Cisco Catalyst core switch. Also, if I take a look at the top, we'll be able to see our connectivity where our ports 1 and 2 are bundled and connect upwards to the Cisco Catalyst switch. If I access the MDF switch, we can see that ports 23 and 24 are bundled and connect up to the Cisco Catalyst switch. Ports 2 and 4 are blocking and discarding traffic, as this would have caused a loop in the network. Ports 2 and 4 connect to the other Meraki switch. This is our topology view for our current layer 2 status for our connections. Our Catalyst switch on ports 1 and 2 is connected to our IDF Meraki switch on port 1 and 2, forwarding traffic. Ports 1 and 2 of the Meraki switch are operating as root ports. We have connections for ports 22 and 24 on the IDF switch, which are connected to ports 2 and 4 on our MDF. Ports 2 and 4 are currently acting in the discarding or blocking state and not forwarding data. Ports 23 and 24 are bundled and connected to the Cisco Catalyst switch, and those are root ports sending data on a pathway up to the Catalyst switch. Our Meraki switches can operate within a vendor-specific protocol deployment. In this case, the proprietary protocol was rapid per VLAN spanning tree with our Cisco Catalyst switch. But just know that you can operate your Meraki switches in environments with other varying proprietary protocols as well.